Hello and welcome to the appendix part. Previously, we talked about gravity. After use it to extract data from the plots, we have to add them to the MATLAB workspace so that we can use them later. Well, when it comes to creating lookup tables, those data are not sufficient. Well, what we've done previously actually is not that straightforward. So what I mean by saying that, let's look at the example we have. Well, if you're coming from the lecture, you will probably recall this plot. This is the direct utility factor versus Mach number plot. And as you can see, we have a missing here. If you look at here, we see that the data between Mach 0.2 is missing. So if we would like to perform a full mission profile analysis, we need those data to be filled. So this is the first problem. The second problem is unseen here. So let me show you by loading the data that I extracted from Gravit to here, and we shall see that. So I will load them one by one. The first thing is here, and I can simply do the same thing again and again and again. We have here again, and finally 0.7 here. So let me run the code. And as you can see, we have the inconsistency where their length is not the same. With this way, we cannot create any lookup table. So here's the situation. We have extracted data from the plot, but their length is not the same to have a lookup table. So what we need to do is to interpolate to a common grid. But before of it, I need to mention that their length difference does not prevent that you can plot them to show and to have this type of plot. So you can plot them even though their length is not the same. But if you want to have a lookup table, you need to have a common grid. So I'm not gonna show you to plot them. I mean to prove them, to prove you. But from the code that I will share, you will see that you can prove yourself that you can plot actually. So therefore, I simply want to create a common grid, which is called Mach common, and I will equate it to 0. I want it to start from 0, and I can make this step size and all the way to 1.2. Well, this is my Mach common, and I want to extend the x-axis to 0 from 0.2, if you remember from here. So this is the first thing I need to do. The other thing is that creating the CL vectors and the CL array, CL cell. So let's create the CL vector, which is equal to 0.35, 0.4. By the way, we are creating a vector, therefore this will be semicolon. And I will simply copy and paste. This will be 7, this will be 6, and this will be 5. Yep, and don't forget that the semicolon, and we need to create an array to be able to create a lookup table. You will see that later. So CL cell, let's say, or data cell, it doesn't matter. This time I'm creating a cell. Sorry, come on, you can do this. All right. Let's say CL 035, and this time, because we are creating this cell, a comma is needed, and finally this. So this will be 7, this will be 6, and this will be 5, and this will be 4. All right, we have this. Now, this is the important part. if we would like to fill those blanks, let's say the first thing comes to our mind is that using the extrapolation tool. However, that will not work because when we extract those data from the figure, we selected those points one by one, and this point and the very near of that point may not be level, so that extrapolation can go down or up. However, from the plot, I can assume that this behavior will go linear and will level until to max 0.0. Therefore, this will not work. But we will have another approach. We have a MATLAB built-in function which is called fill missing. And I'm going to show you actually how it works from the MATLAB help section. It will open up the website, and it actually describes pretty well fill missing entries. Here we have the syntax of it so that we can use them, and we have a description. You can read that, but I want to show you from an example. Right, this is a good example. In this example, we create a bound and we create our function. Then we simply extract some values and assign it to not a number. Then we fill those values, and as you can see, it fills perfectly. So what we're going to do is the similar thing. We will not use a linear thing, but we will fill with the nearest data. What I mean. So let's go back to the plot again. What I will do is that using the fill missing to find this point and assign it to the nearest point, which will be the exact point at Mach 0.2. And when I assign it, I will continue to do that until the 0, and I will have the same same value that's equal to the Mach 0.2 for, let's say, CL 0.35, and I will do it for every CL data I have. So let's go back to the MATLAB. Now I'm going to use this function, but I will use it outside of the interpolation function. Why? Because I want to perform this thing only for this region. For the rest, I need to do my generic interpolation because it works here. We have the data. We are missing data here. So to do that, I'm creating a function that belongs to me actually. I want to call it as save interpolation, and I want to equal it to fill missing function, and I will create an anonymous function. To do that, I'm putting this, and it will accept the input of x, y, and x query. Right, fill missing. I'm opening a parenthesis, and this will be interpolation 1. Because one-dimensional interpolation performed here. So it will accept x, y, and 2. Xq says it helps me here actually. And the method will be linear. And I will say not a number. This means that when I come to not a number, I will go to the fill missing function. So inside the fill missing function, I will assign it to the nearest value here. And this is my function. So you will see that it works inside the for loop. So this is the function. Now I'm going to create my for loop to obtain my lookup table. So let's do that for an end. So for I starts from I starts from 1 to all the way to length of CL cell. That's why I created this. All right. Inside of it, I will create a current data and this will equal the data cell. Let me do this. This is only for storing the data. I mean, if I don't do this, it will finally calculate CL 0.7, and I will have only the interpolation for this. And I don't want that. I want every CL to be stored and inside the current data, so that I can create my lookup table. So we can create now a lookup table. Lookup, let's say lookup K, because this is the drag to lift factor. So this will be like this, because I don't want to have one lookup table. I want to have about 5 rows. No, 5 rows, and all the column will be the Mach number. So let's continue. Now I can call my function save interpolation, and I will simply input my values, which are current data, because I assign it to the current data. And let's do the same thing here. And again, the current data, this time we shall have the second. And this will be 1, by the way, sorry. This will be 1 because I'm getting the first column. Let me show you for an example. I'm getting the first column that corresponds to the Mach number, and the second for the K. And finally, I will have my Mach common. This outside, right? Yeah, this outside. And this is how my function becomes. And at the end of it, if I run this code, I should be having the lookup table. So let's run the code. Yeah. What this is that data cell? Yeah, because it's cell. Also, it's call, not cell. So yeah, lots of mistakes here. So again, let's run it again. And we have lookup K. This is not the way I want it. What we've done wrong. Yeah, I need to do this. Sorry. I did reverse. And if I run the code again, now everything will be okay. Yep. This is what I want. Every row stands to a CL value, and every column is the Mach number from 0 all the way to 1.2. So I've achieved. And finally, we can prove this. To prove, I need to create a simulation environment to myself. For example, let's say we are in the simulation and we have an instance CL value that's called CL current as a value that I can check that my lookup table works correctly. To do that, let's open up the lookup table again. Let's try a point from the plot actually. If I select this point, let's say about this point, I want to have the data of this point. Why? Because, like I said, when we consider the x-axis, I extrapolated or filled this to be the value of Mach 0.2 all the way to 0.0. So I expect this point to become my result. Also, as you can see from the graph above, as a definition, the K, the drag to lift factor below 0.35 CL, should be equal to CL at 0.35. This means that whenever I select about this point, it should be assigned to do this. For example, this assigned to this. So I need to ensure that in my simulation. So we need to ensure this in simulation environment. To do that, let me first select the lookup table I want to say. Let's say I want to obtain this point. I mean, this point corresponds to about this point. So I will select my CL as, let's say, 0.1. And I'm going to select my current Mach. Let's say Mach current as, let's say, 0.1 again. I can close this. Now, I need to perform that thing that I told you. To do that, I'm going to use CL vector paste here, and I want the minimum value of it, which is the 0.35. And we have the value of CL current. So let me put them into a parenthesis, like this. Now, for example, let's say our CL current is 0.1 and my minimum of CL vector is 0.35. So in the simulation, I want this to be selected. If the CL current is higher, let's say 0.7, this to be selected. So either way, I want the maximum of these two values to be selected. Therefore, I'm gonna call my maximum function to complete this thing, and I'm gonna assume assigning that to CL query. CL query, of course, not call. Now, now we're done. We're gonna input the CL query inside the lookup table. Don't you forget that. Now I can call my interpolation to, and this will accept the input of Mach common. Mach common, is it here? Yes. And we also give the CL vector to it. Then my lookup goes in, and my Mach current and CL query. And I want it to be linear. Right, let's run the code. Where is the interpolation? We didn't assign it to anything, so let's make it to k factor. And let's run the code again. And as you can see, we have 0.1254, which is equal to the data we have here. So we did a good job. Our lookup table works. So we have created our first lookup table so that we can use in our simulation. And this is actually the end of the video. I know that it take a bit long, but this is important because this is called data handling. And if you can't do this, the gravity you used from the previous video will not work in your simulation at all. So this also important for any other field of the engineering. So you shouldn't have to be an aerospace engineer. I mean, this data could be a different data, could be belongs to different engineering field. So if you know how to handle your data, you are in a good position. I can really say that. So this is the end of the video. Thank you for your listening and attending, and I'll catch you later.